Hi everyone. In this class we are going to see quotient group. Last class we have seen normal subgroup definition, lemma and two theorems. N is a normal subgroup means G and G inverse belongs to N. Here G is belongs to G and N is belongs to N. In this class we are going to see quotient group and one 10-mark question and 5-mark question. These two are very important. So the definition is, if G is a group, N is a normal subgroup of G, then G by N is also a group. G by N is called the quotient group or factor group of G by N. G by N is a quotient group means G is a group and N is a normal subgroup and G by N is also a group. Next we have to come with the theorem. This is very important 10-mark question. So listen carefully. Let G by N denotes the collection of right cosets of N and G. That is, the elements of G by N are certain subsets of G. Then prove that G by N is a group. Otherwise, the statement is like this. If G is a group, N is a normal subgroup of G, then G by N is also a group. So, by the definition itself, we know that G is a group and N is a normal subgroup means G by N is also a group. This is the definition of quotient group. We have to show that here G by N is also a group. That is, we have to show that it should satisfy 4 properties: closure property, associative property, identity property and inverse property. Here they are mentioned G by N is a collection of right cosets of N and G. So right cosets means we have to define NA, NB. So we have to take 2 elements from G by N means the 2 elements are like this, NA and NB. So we have to come with the proof. The first one is closure property. So we have to show that you have to take 2 elements from G by N. So multiplication of these 2 elements, that is xy is belongs to G by N means we can say the closure property is satisfied. So we have to take x comma y belongs to G by N. So the elements of G by N is of the form NA and NB. So you have to take x is equal to NA and y is equal to NB for every a comma b belongs to G. So we have to show that xy is belongs to G by N. So xy is equal to NA into NB. The product of 2 right cosets of N and G is again a right cosets of N and G. We know this theorem. So N is a normal subgroup here we have. So we can use this theorem. So NA into NB is equal to N into AB. So N into AB is an element of G by N. So it will be surely belongs to G by N. So xy is belongs to G by N. The closure property is satisfied. The second thing is associative property. For associative properties also we have to take 3 elements from G by N. The elements is of the form NA, NB, NC. So you have to take x, y, z belongs to G by N, and x, y, z is of the form x is equal to NA, y is equal to NB, z is equal to NC. Here ABC is belongs to G and xy, z belongs to G by N. We have to show that x into y, z is equal to xy into z. So we have to prove that left hand side is equal to x into y, z. So NA into NB into NC. So here we have the product of 2 right cosets of N in G is equal to again a right coset of N in G. The same statement here is also we have to use. So N into A into N into BC. So again we have to apply the same theorem. So N into ABC. We have to put this is equation number 1. The right hand side part is xy into z. So for xy you have to write NA into NB into NC. So NA into NB have to use the theorem statement NAB. So in the next step is also we have to use the same statement means N into ABC. So 1 is equal to 2. So we can say x into yz is equal to xy into z. So associative property is satisfied. The next we have to come with the identity property. So the identity element of G by N is of the form NE. So we have to show that NE is equal to, that is XN is equal to X. So you have to take the identity element will be N is equal to NE, that is belongs to G by N. We have to take the element X is also belongs to G by N. We have to show that Xn is equal to X. So Xn is equal to X means here N is the identity element, N is equal to NA is of the form of G by N. So Xn is equal to Na into Ne, because X is equal to Na, N is equal to Na, already we are assumed that. So Na into Nb is equal to N into Ae, because the product of two right cosets of N in G is again a right cosets of N in G. So here Na, instead of Na you have to substitute X. So X into E means E is the identity element, so we get X. So X into N is equal to X means here N is the identity element. So Ne is the identity element of G by N. So the identity property is satisfied. So the next we have to come with the inverse property. X belongs to G by N means X inverse is also belongs to G by N. So here we have to take X is equal to G by N, then X is equal to Na, for A is belongs to G, thus surely it will be exist. So Na inverse is also belongs to G by N. Here we have to show that X into X inverse is equal to E. So Na into Na inverse is equal to Ne means inverse property is satisfied. So we have to come with left hand side. Na into Na inverse is equal to N into A inverse. A into A inverse means that will be E. So Ne is belongs to G by N. So Na inverse is the inverse element of G by N. Therefore inverse property is satisfied. So G by N is a group. Here surely it will be satisfied identity property, inverse property, closure property and associative property. So directly we can say G by N is a group. So this is very important 10 mark question. So listen, study properly. The next will be how to come with the 5 mark question. This is also very important 5 mark question. So the statement is, if G is a finite group and N is a normal subgroup of G, then order of G by N is equal to order of G divided by order of N. So for the proof, here they are given G is a finite group and N is also a normal subgroup. Already we know that G by N denotes the collection of right cosets of N in G. So this will be the collection of right cosets of N in G means order of G by N will be the number of right cosets of N in G. The number of right cosets of N in G is equal to the definition of index. So this will be equal to index of N in G, that is Ig of N. So Ig of N we already know the definition. So Ig of N will be order of G divided by order of N. So this will implies order of G by N is equal to order of G divided by order of N. This is also proved. So today we have seen one 10 mark question and 5 mark question. Both the questions, both the theorems and lemma will be the very important one. So you have to study today itself. Thank you.